Alrighty, this time I want to get into macros. So macros in general provide us with a way of rewriting source code, possibly before it gets interpreted or compiled, to provide additional syntax flexibility for the developer. It's kind of an expansion on the existing language syntax. So usually it's some sort of a pre-processing step where, the developer writes the code and they can, so the person making use of the macros, let's say, is able to write their code as if the macro was part of the language. And then as the code is compiled, first some kind of macro processor runs and translates the code that the developer wrote into stuff that's really valid in the source code language. So for the developer, it looks like they can use any of this syntax, but behind the scenes, it's actually getting transformed into, if you like, real C or real C++ or real Lisp. Different languages provide different degrees of macro capabilities. So for some, it's just kind of aliases or shortcuts for commands. Some allow you to just do straight command substitution, like replace one set of text with another, or to use templates. So things like the hash defines in C are just sort of straight text substitution. Things like the templates in C++. Some other languages allow you to actually write, if you like, a full programmatic macro where we can have a macro with parameters and things that actively rewrites things. And that's what we'll take a look at in Lisp for this next little while. So it can get really interesting. All right, so in terms of the macros for Lisp, when you see them, you're going to see they look a lot like functions in terms of defining these things. But again, these run as a pre-processing step. So they run before the code actually ever executes. So these are, the data that they're working on is the code. So they're not working on whatever content variables and things are going to have as the program executes. This is all happening before execution can ever begin. And the big idea is that they allow the programmer, the macro programmer, to go through and create some kind of new syntax to effectively add to the language. A new way to allow other developers to say something in a new syntax that then gets translated into the existing correct language syntax, if you like. So wherever the compiler sees this new syntax in use, it runs that macro to go through and translate it into the correct syntax for the language. And once all of the macros have been completed, then the Lisp code can run, the real Lisp code, if you like. So again, the macro processing is kind of a pre-processing step. So we'll just start off with a really simple example to show you what I mean. So let's say in Lisp, I want to be able to use this as syntax. I want to be able to say nullify x as a shortcut for setting x to null. So, or to set x to null. So if I write nullify foo, then it sets foo to nil. If I write nullify blah, it sets blah to nil. And so what I want to be able to use this syntax, but then what should happen behind the scenes is that before the program actually runs, that gets rewritten as, just set foo to nil, or set x to nil, or set blah to nil. So I'm going to create a macro that supports this kind of a rewrite. So I'm going to call it nullify, and we use def macro. So we've got defun for creating functions, def macro for creating macros. So def macro, I give it a name, and then I specify what kinds of parameters it expects. So these are elements of source code that it's expecting to work on. So this is going to be, the x is going to wind up in our var name, or the foo is going to wind up in our var name. And what I want to rewrite it as, don't worry about the backtick for a moment, I want to rewrite it as setf, and then whatever the x or foo or blah was, and then nil. So this is the code that I want to produce with the x or foo or blah dropped in the middle here. So if I throw this macro in, so I define my new way of rewriting the developer's syntax into something else, and then the programmer says something like nullify foo, again, it's going to apply this macro to rewrite this and say, okay, well, where the nullify foo was, I'm going to write setf foo and nil. so the source code gets transformed into this before it begins to execute. All right, why bother? Why not just do this as a function? So create a function call that says, I'll define a function nullify where you pass me the variable name and I'll set it to nil. Well, two problems there. First, again, this setf varname to nil is setting that parameter to nil. It's not setting the original value to nil. So, pass by value, this isn't actually going to work. It's not going to change foo. But the other advantage to using a macro instead is the macro would have stuck a set foo to nil right here. It wouldn't have the overhead of making a function call to set this thing to nil. So the macros are actually more efficient in terms of runtime behavior. So then the flip side is, well, if macros are more efficient, why use functions at all? Well, the problem is that the macros are introducing this extra kind of hidden layer to our programs where they're going through and taking what you wrote and they're rewriting it into something else, and that something else is what gets executed. So if there's a crash or something goes wrong, that crash is going to be based on whatever this stuff got rewritten to. And so the error messages that you get, the runtime behavior that you get, the runtime disasters that you get are going to be based on all of this transformed code instead of what the source code looks like to you, the programmer. And that can make debugging really tricky, especially since our macros can actually use other macros, and they can actually even be recursive. So you can have this macro that uses these other 3 macros that use these other 3 macros, and this one's a recursive macro that uses these other 5 macros. And so there can be this huge amount of rewriting taking place. And if we're using macros for practically everything, then the code that actually runs in the long run is going to look nothing at all like what we originally said in the source code language, what we originally wrote in the source code language. And if there's a bug in one of these macros that we have to debug, it can get really tricky to try and figure out where on earth the mistake in rewriting is happening. So replacing functions with macros is not something that you want to do just at the drop of a hat. You want to have a good reason for it. So usually the idea is we'll use a macro where it can significantly improve the readability of your code, right? Providing a simple syntax for the developer that they use frequently. And when you're looking at maintaining decent runtime performance, so where you're looking at avoiding runtime function calls. And there are times when there's something that you simply can't do easily through a function call, like that nullify example, right? Using a macro for that does allow it to set whatever we give it to 0 or to nil rather than our pass by value parameter. All right, so back to the syntax side of things. If you recall, way back when we had this syntax that said, backtick, setf, comma, value, foo or something, or whatever it was. So the idea is with our macros, we're saying I want to take this chunk of code and rewrite it into something else. So I need to provide literal code in the macro where I'm saying this and this and this and this and this I want to actually appear as part of the new source code, the rewritten source code. But in these other spots, I want to introduce the data that was passed to me. So for instance, the x or the foo or the blah that was passed to that macro parameter x, for instance. So the backtick means whatever's coming up is exactly what I want written in as the final source code. So if I say backtick, open bracket, blah, 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 close bracket, then what's going to appear in the source code resulting from that is actually the open bracket, blah, 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 close bracket. Where we throw the comma in is within that chunk, within that backticked chunk. If I actually want to use something as a variable in there and insert the contents of the variable instead, I throw the comma in front of it. So comma x actually means use the value that's in x right now rather than the word x or the text x. So our nullify macro back there had our def macro, nullify for the name of it, and then there was some variable that we wanted to nullify, and so my backtick, and I want the text to be setf, and oh, I'm missing a null there. Setf my comma varname, so whatever value is in varname would go here, and then my nil, if I hadn't actually forgotten it on the slide. So we're going through and using pieces of this literally, and other pieces we're substituting with the value of a parameter. And again, remember, it's the chunk of source code that got passed to this. So in the nullify foo, foo is that chunk of source code that's in here, and so the foo is getting pasted in here. All right. So the code that we generate can be as complex as you like, right? That nullify was pretty straightforward, but maybe I want to do things like say, well, before I just try and blindly set something to nil, maybe I should make sure that it's actually a symbol and that it's actually bound. So maybe I could say something like, well, if, actually maybe I'd throw in an if symbol p, or if and symbol p varname bound p varname, where I use the comma varname to say whatever variable name you actually passed me, whatever identifier you actually passed to me, paste it in here. So if it passes those tests, so the rewritten code would be, you know, if that thing was actually bound, so it was actually a variable that was set to something, then set it to nil. Right? So this is the idea of going through and saying, okay, well, my macros should probably take into account some of the possibilities, some of the error checking that should take place at runtime when this happens. So we're looking at rewriting our code in a fashion that will give appropriate runtime behavior. Now, again, debugging is kind of an issue with macros, so it's handy to be able to go through and see, if we've got a macro, see what it turns into, what the result turns into. So there's a macro expand -1 where you give it the macro call that you want to examine, so nullify foo, for instance, and it will return whatever that gets turned into. So in this case, it would actually return the list, you know, if bound p foo, set f foo to nil. So that gives you a chance to do some debugging on this. Now, I mentioned earlier that macros can be recursive. The macro expand doesn't do the recursive expansion. It only shows that first layer of expansion. So, and unfortunately, you can't use the -2 or -3 or something like that to get further layers of this. So we can go through and get one layer of macro expansion, which at least helps with the debugging. All right, there are lots of other issues that we should try and address when we're dealing with macros. So one of them falls into the category of, suppose I want a local variable in the chunk of code that I rewrite. So for instance, I want to introduce, in the code that I'm generating, I want to introduce a let block with a local variable. So here, let's say I wanted to have a swap macro, where I want the user to be able to say something like swap x and y that, you know, does the usual, swaps the two values. So if we take our usual kind of swap idea where we say, well, let's create a temporary variable, store x in that, store b in, or create a temporary variable, store a in that, copy b to a, and then copy that stored temp value back into b, we could say something like this. Right, and this seems to make sense, where I'm going to create my let block. Right, so this is what the, ooh, I'm missing a backtick. Oh, bad programmer. So I'm going to go through and create a let block that has a temporary variable that I'm going to, so in my let block, it's going to say, okay, write this out as a variable a, or variable temp gets assigned whatever that first variable name was passed to it, right? The value that's in A right now, the identifier name that's in A right now. And then I'll throw in my code to say, okay, well, after that, you know, assign whatever this one is to whatever that one is. And then a final setf to say, okay, well, whatever was in that temporary variable, stick in the second parameter. So if I said something like swap xy, this is going to come out as, you know, let this temporary variable x or temp be initialized to x, set x to y, and set y to temp, which makes sense. It's going to work perfectly well. The only problem comes in when the name that we're using inside the macro is one that's already in use. So if somebody said swap temp with z, and they'd have no good reason, if you're not going through and looking at the definitions of the macros, you just know that this swap syntax is provided for you, it would make sense to be able to say, okay, well, I want to swap temp with z. But what that would mean when this macro rewrites it is it's going to use temp wherever a is, so it's going to say initialize temp to temp, set f temp to z, and then set f temp to temp. And of course it's not going to work the way you want. So I would like some way to be able to have a new unique variable name inside my macro, inside my let block here. And that's where this gensym function is going to come in. Gensim generates a new variable name for us that's guaranteed to be unique, a new identifier, a new unique identifier. So you just call gensym, right? It's just a function, and it gives you back a new variable name that's never been used before and won't clash with anything else in the program. So what we'll do is, in our macro, we'll actually we'll get the name from gensym in a variable, and we'll use that variable as the name, or the value of that variable, the value in that variable as the name that will stick into the source code that the macro generates. So we'll have our macro swap that's taking its two parameters a and b, and we're going to have a let block. So this isn't going into the source code that's getting generated. This is actually a let block for the macro itself. So the macro is going to have a local variable temp that we're going to call gensym, and whatever name it gives us, we're going to store in temp. So it's going to give us some new weirdo name, and we're going to store that in temp. And then in the code that we generate, I'm going to go through and say, okay, well, whatever weirdo name you gave me, use that as my local variable name, and whatever name they passed is used to initialize that. And again, our usual, set whatever the second thing was to whatever the first thing is, or set, assign our values from b to a, and then assign, and again, we'll use whatever name that gensym came up with as the name of the variable to assign to b, or whatever they passed for b. So now, if somebody says swap x and y, then I'm going to, for the example here, I'm going to assume that the name that gensym comes back with is something like G123. So our generated code block is going to look something like, okay, well, let's generate a let block, and in that we'll have this local variable G123, and we'll store x in that. We'll copy y to x, and then copy whatever was in this G123 to y. So you can actually create these new unique identifiers on the fly. So now we've got the let block that's got the variable for the macro, and then it's producing code that's got a let block that's making use of that variable. Lots of fun. All right, just a couple of other bits and pieces. There are times in a macro when we wanted to take the contents of a list and not just treat it as a variable, but treat it as the elements that are in it. So let's say I've got a macro where I want to be able to do things like so if I want to say plus and somebody gives me a list of arguments, I want to be able to rewrite that as the addition operation and then the arguments. So I want the 10, 20, 30 actually embedded right in there. Right? I don't want it to be plus and then this list 10, 20, 30. And again, if I just try def macro plus and then L, and I say the code I want to produce is a plus and then whatever L is, again, that's going to come up with plus and then this list 10, 20, 30. Not what I want. So if you use comma at, that says take whatever the contents of the list are and dump those elements in. So now if I do my def macro, my parameter, and this time, produce as output the, open bracket plus, and then dump the elements of L in here and close it off, then I'm going to get the syntax that I want. All right, we can actually write recursive macros. I mentioned that earlier. So it's much like using variadic parameters in our functions, where you can throw in and rest and then some variable name afterwards. And that's basically just saying, okay, there can be a whole bunch of additional parameters. And so you can make the macros recursive. So for instance, the the and is actually implemented as a macro using if statements. So if somebody says and W, that's just going to get translated into W. If somebody says and WX, that's going to get translated into if W, then X. Right? So if W is true, then if X is true, it returns true, and otherwise it returns false. Again, similar sort of idea. And WXY is going to get translated into if W, and then it does the recursive version here for the and XY. So it says if XY. Or again, if you've got and WXYZ, then you get that top layer if W, and then it does a recursive application of XYZ. So there we get the if, X, which is just the one we did a moment ago for a 3-parameter version. So you can start going through and writing these recursive macros as well. So again, for and, this might look something like, we'll just say you can take any number of additional arguments. If they call and with nothing, then we'll just say, okay, well, that's true. I'm just going to pick and of nothing is true. If they give and of just one thing, then I'm going to say, okay, it's just the one thing, right? Because it's going to be true if that thing is true and false if it's not. So if that thing is nil, it's false, and if it's anything else, it's true. So if we take a look at that list of arguments, if there's only one thing in there, then all I want to do is use that front element. So I'll just use the car of the arguments. And in the general case, where there's more than one thing, then I'm going to rewrite it as an if, and the first thing, and then a recursive call. All right, so I'm going to say, okay, for my general case, I'm going to rewrite it as an if, where we throw the front thing in first, and then I'll do a recursive macro call to get the rest. So I'm going to say and I'm going to dump, again, use that comma at to dump the list of the rest of the arguments in there. And I can get my recursive structure implemented. Lots of fun. So the actual implemented syntax in Lisp is really small. There's just a handful of features in Lisp that are directly implemented in C or whatever it's built in. So most of the features that we use are actually macros that translate our code into, well, other macros into other macros into other macros that eventually boil down to these core Lisp elements. So all of the things like and or and loops and cases and cons and blocks and let blocks and stuff, it all gets translated into something else that's simpler, purer Lisp. But it gives us all this functionality, all this syntax that's convenient for us to use as programmers. And again, the idea is this was all built up very incrementally. You come up with a macro that can replace a macro for con that turns it into a bunch of if-elses. You come up with a macro for and, like the one that we looked at, or a macro for or. And then you just keep building more and more things on top of this until you wind up with a very diverse set of features that you can use as a programmer in the Lisp language. And behind the scenes, it's all getting translated before this thing actually starts to run. And if you want to use, if you want to create new features to add to Lisp when you're playing with it, then again, you can build up your own macro suite for doing this kind of thing. And most of the kind of commercial applications of Lisp do this very heavily, where they're saying, okay, there are things that we do frequently where it would be really handy for my business application to be able to have this simple syntax to do whatever. And so you build a suite of macros and you debug and expand this suite of macros to give you that functionality so that your developers can do those things very easily in writing the source code, but it's still efficient behind the scenes, right? You're still not introducing these huge layers of function calls and whatnot. All right, so we will play with macros just a little bit in the labs. We won't get into it too deeply, but it's definitely one of the most interesting features of Lisp. All right, I will leave that one there for now.